In level 4, we will be using something called the rational root theorem to find all of the possible zeros of a polynomial. Now, I have a little typo on here. That should say level 4. Sorry about that. You can fix it on your paper copy too. The rational root theorem says if you have a polynomial in standard form that starts off with your highest degree term, or your term with the highest exponent, and goes down to your constant term, you're going to look at your very first term and your very last term, which is your constant term, and p is a factor of the constant coefficient a sub 0. So p is going to be factors of that constant term. Okay, and q is going to be all the factors of your leading coefficient a sub n. So q equals the factors of the leading coefficient. Okay, so looking at this first example, my constant term is -9, and p is going to be factors of -9. So p can equal, think of all the things that multiply to 9. 1 is a factor, and we're going to do positive and negative factors. So plus or minus 1, plus or minus 3, and plus or minus 9. Those would be all the factors of -9. Okay, then q is going to be all the factors of the very first number, so the coefficient of the term with the highest exponent. And since it's a 2, the factors of 2 are plus or minus 1 and plus or minus 2. Always take both positive and negative factors. Then the rational root theorem says that all of the zeros of the polynomial will be in the form p over q. So what I have to do is I have to find all possible values of p over q. So I take every combination that I can with p on top and q on the bottom. Starting with the plus or minus 1 for p and plus or minus 1 for q, if I put 1 over 1, I would just get plus or minus 1. Okay, then I'm going to do plus or minus 1 on top over plus or minus 2, and that gives me plus or minus 1/2. Okay, next I would do plus or minus 3 over plus or minus 1, which gives us plus or minus 3. And then I would do plus or minus 3 over plus or minus 2. And we get plus or minus 3 over 2. Okay, then I would do plus or minus 9 over plus or minus 1, which is plus or minus 9. And then plus or minus 9 over plus or minus 2, which is plus or minus 9 over 2. Now, we've made a list of a lot of numbers, and these are the possible zeros of this polynomial. These are the only numbers that would be rational zeros for this polynomial. My next step is going to be to test these possible rational zeros and see which ones actually give me 0 when I plug them into f of x. So I try plugging numbers in until I get one that actually makes f of x equal 0. So I first find f of positive 1. So I'm taking the positive 1 p over q. And if I plug in 1 for all the x's in f of x, I get 2 minus 5 minus 16 minus 9. And I just want to know if it equals 0 or not, and that definitely does not equal 0. So that is not going to be one of my rational zeros. So I'm going to just erase that in the interest of space, and I'm going to try another number. So I'm going to try plugging in -1 and see if that gives me 0. If I plug in -1 to all these x's, 2 times -1 to the third is going to be -2. 2 times, or when I plug in -2 to -5x squared, that's still going to be -5. and then I'm going to get plus 16 and minus 9. And does that equal 0? This time, yes, it does. So negative 1 is one of the zeros of the polynomial. And since I found one, I don't want to continue and test all these numbers because that will take a long time. Once you find one, you can use polynomial division to find the rest. So one of the zeros of this polynomial is going to be negative 1. And since negative 1 is a 0, if I wanted to write this polynomial in factored form, I can write f of x equals, if we have 0 as a negative 1 as a 0, x plus 1 would be a factor. And so if I divide the polynomial by x plus 1, I'll get the other factor, and then I'll be able to factor from there. So I'm going to use synthetic division to divide f of x by x plus 1. Remember, when we do synthetic division, we put the number that makes that part equals 0. So I put negative 1 in the front, and then my two shelves. On the top, I put the coefficients of f of x, which are 2, negative 5, negative 16, negative 9. I bring down the 2, and I multiply. Negative 1 times 2 is negative 2. I add. Negative 5 plus negative 2 is negative 7. I multiply. I get positive 7. I add, and I get negative 9. I multiply. I get positive 9. I add negative 9 plus 9, and I get 0, no remainder, which is good, because it should be factorable. And so f of x is x plus 1 times 2x squared minus 7x minus 9. And from there, I can just use factoring to completely factor this polynomial. So we have x plus 1, and then 2x and x. And we need two things that multiply to 9. So I'm going to try 9 and 1. And I want a minus here and a plus here. And a simpler way to write that would be f of x equals x plus 1 squared times 2x minus 9. In this next example, we're going to be taking the same steps as the last one. We want to write the polynomial in factored form, and our goal this time in the end is to graph it also. So the first thing we want to do is find all our possible values for p over q. So remember that p is all the factors of your constant term. So p could equal plus or minus 1 and plus or minus 2. And then q is the factors of your leading coefficient, which is 1. So q can only be plus or minus 1. And then for p over q, we find all the possible p over q combinations. We could have 1 over 1, which is plus or minus 1, and we could have 2 over 1, so plus or minus 2. So this time there are only 4 numbers that are possible zeros for this polynomial, possible rational zeros. And so I test them. So first I'm going to test k of 1, because that's the easiest number to plug in. If I plug 1 into k, I get 1 minus 3 minus 2. That does not equal 0, so that's not going to be one of the zeros. Now I'm going to try negative 1. If I plug negative 1 in, I'm going to get negative 1 plus 3 minus 2. That does equal 0, so I found one of my zeros. So one of my zeros is negative 1, and I don't want to test You could test positive 2 and negative 2 and see if those work and do it that way, but I'm going to use synthetic division to finish factoring the polynomial. If negative 1 is a 0, a factor is going to be x plus 1, and I want to figure out x plus 1 times what. So I divide k of x by x plus 1. Using synthetic division, I put a negative 1 in the front. My coefficient for x to the third is 1. I don't have an x squared term, so I put a 0. My coefficient for x is negative 3, and my constant is negative 2. I bring down the 1, multiply, I get negative 1. Add 0 plus negative 1 is negative 1. Multiply, I get positive 1. Add negative 3 plus 1, I get negative 2. Multiply, I get positive 2. Add negative 2 plus 2, I get 0. So my function, k of x, was x plus 1 times, my answer for synthetic division is x squared minus x minus 2. And then I can continue to factor that. I get x plus 1 times x minus 2, x plus 1. And I could rewrite that. K of x equals x plus 1 squared times x minus 2. And now this time I want to actually graph it. So I'm taking it a step further from just writing it in factored form. I want to find all the zeros. So negative 1 was a 0 and positive 2 is also a 0. And so I need to have an x-intercept at negative 1 and positive 2. And then I need to find the y-intercept when I graph. So remember, we always plug in x equals 0. If I plug in 0 for x, which is easier to do up here in expanded form, I'm going to get the point 0, negative 2. So my y-intercept is negative 2. And the end behavior, since I have, looking at my very first term, x to the third, it's odd degree with a positive leading coefficient. So the end behavior is going to be down over here and up over here. So I start down below and go to my first x-intercept, negative 1, where I'm supposed to bounce. So I bounce, I go down through my y-intercept, and then I have to cross at my other x-intercept. And that would be the graph.